Hi guys, this is the final exam review. These are some things that I think you guys should know before going into the exam. Okay, so first of all, know when a function is continuous versus not continuous. For example, if we have f of x equals 2 times x squared plus 9x plus 9 over x squared plus 13x. Actually, I want to change some of these numbers to make my life not so awful. Let's just do x squared plus 5x plus 5. Okay. And I want to know which of the following are true. So if I ask you, is it continuous at a equals negative 5? Sorry, at a equals negative 13? Not continuous because f of negative 13 is undefined. Not continuous because the limit as x goes to negative 13 of f of x does not exist. Or not continuous because the limit as x goes to negative 13 of f of x does not equal f of negative 13. I want you guys to remember that all three of these reasons are reasons for this not to be continuous. So, let's see what happens if we just plug in our value negative 13. So f of negative 13 is equal to 13 squared plus 65, minus 65, plus 5 over 13 squared minus 13 squared. So that gives us, God, what is 13 squared? I honestly could not tell you guys. Hold on. 13 times 13, 169. Oh, I should have known that. My brain has been fried. 169 minus 60 over 0. So this is going to be 109 over 0, which we know goes to 1,000. Because I can fit 1,000, sorry, not 1,000, infinity. I can fit an infinite number of zeros into 109. And so this isn't one of those cases where we need to do L'Hopital's or any algebraic thing. We just know that this is some number over 0, which we know is infinity, and so that means that this function does not exist. Or sorry, this limit does not exist. Yikes. This does not exist. That this is undefined. So we know that this guy is true. Okay. Now we have to see what the limit as x goes to negative 13 of f of x is. And that's actually going to be the same answer. It's going to be 109 over 0, which is infinity. But remember, infinity equaling infinity is not a thing. Okay? So first of all, this means our limit does not exist. So this guy is true. And it's also not continuous because our two limits are not equal to each other. Am I lying to you guys? Oh, I know why. Okay, ignore me. I'm being really stupid. Okay. I've spent way too long on my finals. It's also not continuous because this is actually going to be a negative infinity. And the reason that's going to be a negative infinity is as, in the denominator, we have okay, hold on, guys. My brain has absolutely died. Okay, let's take the limit as x approaches negative 13 from the positive side. We're going to get 109 over 0. But if x is approaching 13 from the positive side, then this guy will actually be positive. So this is going to be putting us towards a positive infinity. If we approach the limit as x goes to negative 13 from the negative side, we get 109 over 0. But it's actually going to be negative because this denominator will be a negative number. If we plug in a number bigger than negative 13, then this will be a negative number. Am I lying? I don't think so. Oh, yes? This is the negative one. Sorry. This is the positive one. I'm so sorry, guys. But whatever, that was a disaster. Anyway, so this limit does not exist. And so we also have that the limit does not equal what it's evaluated at. The limit is both negative infinity and positive infinity, so it can't equal infinity. Okay, there we go. That's that answer. I'm so sorry. Let's move on. Okay, so let's see here. In the exam, it wants you to use the limit definition to find the slope of a tangent line. Don't do that. Technically, the limit definition is something you guys are supposed to know, but we know that the slope of the tangent line is the derivative at that point, and so why not just take the actual derivative? Right, you guys know the power rule. Don't waste your time doing the limit definition. So let's do an example really quick. Let's do find the equation of a line, of the line technically, tangent to f of x equals x squared plus 3 at p, at the point P, which is, let's do 2, 7. Okay, so if I want you guys to find the equation of the tangent line at this point, first of all, we need to find the derivative, which is the slope. So to find the slope, we'll take the derivative. We have f prime of x is equal to 2x. That's the part you would use the limit on. Why would you use the limit when you have this tool? I guess you technically could, but it's not necessary. Think smarter, not harder. Okay, and so f prime of 2, so that's saying the slope at this point, where x is equal to 2, is 4. So that's the slope of your tangent line. And now the equation, we'll use point slope form. we have y minus y1 equals m times x minus x1, where we leave this y, this x, and the m is our slope. So we have y minus 7, we're getting our 7 from this point, is equal to 4, which is our slope, times x minus 2. Again, that 2 is from this guy. And then we want to simplify it so that we're solving for just y, and we have y is equal to 4x minus 8 plus 7. That's just me moving this 7 over and factoring this guy out. And that is 4x minus 1. Okay, so that'd be the equation for your line. I just wanted you guys to remember that and to know that you don't have to use the definition of the derivative, because that would take too long. Okay, I wanted you guys to remember chain rule. So let's say h of x is equal to f of g of x. Okay, then we know that h prime of x is equal to f prime of g of x times g prime of x, right? We took the derivative of the outside, our f function, left the inside, and then multiplied by the derivative of the inside. Okay? So then if I were to ask you, say, what is h prime of 2? Then h prime of 2 is f prime of g of 2 times g prime of 2. So first you have to figure out what g of 2 is. So let's say g of 2 is equal to 3. Then we'd have h prime of 2 is equal to f prime of 3, because that's what g of 2 gave us, times g prime of 2. Okay? That's just an example. We did a bunch of those at the beginning of the year using like tables of numbers. So hopefully you remember that. I want you guys to remember implicit differentiation. So that was where we were asked you to find the derivative, say dy dx, for some function that isn't solved for y already. And so we would do implicit differentiation so we didn't have to solve for y. So let's say we had cosine of y plus, let's do x squared equals y. Okay, so then I take the derivative of both sides. So the derivative of cosine of y is negative sine of y. And then we have to remember that y is technically a function of x when we're doing implicit differentiation, right? Y is something that we haven't solved for, so we have to think of it as like a chain rule kind of deal. So we took the derivative of cosine of y, and then we have to multiply it by the derivative of y, which is just dy dx, plus the derivative of x is easy. We have 2x, and then the derivative of y is just 1, and then we have to remember to multiply by dy dx. Okay? And then our whole goal is to find dy dx, so we need to put everything with dy dx on one side and everything without it on the other. So I'm going to have 2x is equal to dy dx plus sine of y dy dx. And then I can factor out a dy dx on the right-hand side, so I get 2x equals dy dx times 1 plus sine of y. And to solve for dy dx, I just need to divide, and I get 2x over 1 plus sine of y is equal to dy dx. Okay, that was what implicit differentiation was. All right. Be careful for questions where they ask you to pick more than one. That's all I'm going to say on that. Also remember that, let's see here. What's the derivative with respect to x of the natural log of 4? This is just a number, right? So that's 0. What about the derivative with respect to x of e? This is, again, just a number, and it's 0. Okay. There's some basic integration, but we covered that in the last couple chapters, so if you've been paying attention, hopefully you know what's going on in there. Just your basic indefinite integral. Remember to add a constant c if you're not given an initial value, so just be careful for that. So you might get asked the integral of, let's say, x cubed plus 3x squared, I don't know, dx, and we know that that is, we're raising the power on our x's, so our x cubed becomes an x to the 4th divided by our new power, which is 4, and then we have 3x raised the power of 2 to the power of 3 divided by 3. Those technically cancel. And then we have to remember to add a plus c because we don't have any bounds, and we haven't been given an initial condition. If we are given an initial condition, then we can solve for what this value of c is. So let's say, let's call this function s of x. Sorry, I was thinking s of t, but normally, let's just call this guy f of x. And let's say we were given an initial condition f of 0 is equal to 3, then I would know that this f of x equals x to the 4th over 4 plus x to the 3rd plus c. If I plug in a 0 there, which would be 0 divided by 4 plus 0 plus c, which is just c, has to be equal to 3, because that's what my initial condition told me to do. So I would get c equals 3, which means my actual function is f of x equals x to the 4th over 4 plus x cubed plus 3. Okay. Let's see here. I want you guys to remember that if s of t is position and v of t is velocity, then the derivative of s of t is equal to velocity, which also means that the integral of velocity is equal to s of t. Okay. I want you guys to remember what a right hand and a left hand Riemann sum looks like. Let's say we have this graph, then the right hand Riemann sum, if we're dividing it up on these. Guys, is where we go up and have the right hand side of our rectangle touch our line, right? So we go from the right hand side is what's hitting our line. Again, right hand side is hitting the line, right hand side is hitting the line. Okay? The left hand is the opposite. We start from the left hand side hits the line. Again, left hand side hits the line, left-hand side hits the line, and left-hand side hits the line. Okay? So I just want you guys to know the visual difference of those. If I were to give you like a function and say this is f of x, right? And I wanted you to calculate the integral of f of x dx. That's the area underneath that curve. But if I wanted you to estimate that, then I would want you to calculate, say, the right-hand Riemann sum. If I had you calculate the right-hand Riemann sum using these guys, I would use, let's say this is 1, 2, 3, 4, 5. Then these each have a width of 1. And I just need to calculate the area of the rectangle, so all I need is the height. And the height is going to be the f of x where it hits the line, right? So it would be, if I did the right-hand Riemann sum, I would have 1 times f of 2, because that's the height of my first rectangle here, right? F of 2, that's the height, plus 1, that's the width, times f of 3, because in this case, that's the height right here, and then plus 1 times f of 4, and 1 times f of 5 for my 4 rectangles. For my left-hand Riemann sum, it would be, if this is 1, 2, 3, 4, 5 again, it would be 1 times f of 1 this time, because we're using this guy as our height at 1. And it would follow the same pattern as the other one, where I'd have 1 times f of 2 plus 1 times f of 3 and 1 times f of 4 for my 4 rectangles. Okay. Let's see here. I want you guys to remember that, what number are we on? 9? The integral from a to b of, say, 3x squared plus 2x dx is the same as the integral. We can pull out our constants, so 3x squared dx plus the integral, pull out our constant again, of 2 times the integral of x dx, and we use the same bounds. Okay, that was one of the integral rules that I taught you guys for definite integrals. I believe that was section 5.3, unless it was section 5.2. 5.2. Okay. Remember that if you don't know what a function looks like, then you should graph it on Desmos. If you need help. And this, remember that area underneath a curve is area underneath, let's say we have a graph, sorry guys, hold on, that looks like this, and I want to know the area from this point, so I guess the graph would continue on, but I want to know the area from this point to this point, then that is from here, oops, sorry, I didn't mean to be erasing, from here to here. I want to know this whole area, right? That's the integral under this guy, say this is f of x, then the integral of f of x dx is equal to the area of this guy. Given that this is positive area, and this is negative area. Okay, so you would calculate whatever the pink area is and subtract whatever the orange area is. Okay, also, hint, hint, hintity, hint, hint, the area of a triangle is base times height, where if this is your triangle, will it draw a triangle for me? Here we go. This is your height, and this is your base. Okay. What else? Remember another comment on this guy up here? The integral gives you net area. So that's what subtracting the area underneath the graph is giving you. If you wanted total area, it's just this whole thing. There's no negative portion. It's just the area of the shape itself. Okay. Remember how to use the fundamental theorem of calculus. So there are two things the fundamental theorem of calculus taught us. Let's see here. Let me do a quick example. What number are we on? 11. Fundamental theorem of calculus. If I asked you to take the integral from 0 to 2 of x, let's literally just do x squared. I don't feel like doing anymore. Dx, then that would be, we increase our power by 1, divide by our new power, and then we need to evaluate from 0 to 2, and we first plug in our top number, so we're going to have 2 cubed over 3 minus our bottom power, which is 0 cubed over 3, which is just 0, so this would give us 2 cubed over 3, which is 8 over 3. Okay, that was the fundamental theorem of calculus. And then for number 12, this is also a fundamental theorem of calculus thing. If I had, let's see here, we're going to do things in dt, 0 to x squared of dt over, say, t plus 1 dx. Sorry, not dx, dt. But we're taking the derivative, dx dt. d dx. Oh my god, I'm so sorry, guys. I'm mixing up my dt's and my dx's. Okay, so if I'm taking the derivative with respect to x of whatever this function would integrate to, right? If I took this integral, it'd be in terms of x because we'd be plugging in this top bound. And then if I take that derivative, the fundamental theorem of calculus tells us that it's just plugging in, so this is 1 over, plug in that top bound, x squared plus 1 for your, wherever you had a t, okay? So we plugged in our x squared, and then we want to multiply by the derivative with respect to x of x squared. So whatever your top bound is, you want to take the derivative and use the chain rule for that guy. So that will give us, the derivative of x squared is 2x, so it'll be 2x over x squared plus 1. Okay? That was the second portion of the fundamental theorem of calculus. Let's see here. Okay, odd and even functions. So I am thinking. Okay, let f of x be an odd function and let no, that's not gonna work. Okay, sorry, let this be an even function and let the integral from -2 to 2 of f of x dx equal 3. Then if I could ask you a couple of questions. First question, find the integral from 0 to 2 of f of x dx. And that's just going to be half. Remember, an even function means that it matches on like both sides, right? So if this was the area from -2 to 2, then the area from 0 to 2 should just be half of that, so that should be 3/2. And I could also ask you to find the area from -2/2 to 2 of x times f of x dx. Now that might be kind of confusing, but remember, an odd function is just a polynomial. And if we multiply x by a polynomial, let's say this is x, or sorry, this is an even function, so this is like x squared, right? If I multiply x times f of x, that's going to be x times x squared, which is x cubed, which is an odd function. Right, so this guy down here is odd because f of x was even, and we know that an odd function, the integral from -a to -a, the same two things, of an odd function is just 0. So we could also calculate that. Okay, I think I have one more thing. Oh yeah, just average value. The average value of f of x on the interval a to b is 1 over b minus a times the integral from a to b of f of x dx. And again, if you have trouble graphing things, try to graph it on Desmos. That's supposed to be a b. Anyway, okay, those are my hints for this final exam. If you haven't already taken it, good luck, guys.